My name is Young-Seong, Smart Space Lab Graduate School of Techno Design, Architecture at Hoon University. Content, background and purpose, method and scope of research. Result, conclusion, reference. Performance evaluation of dual light shed system for nature light. Background and purpose. The energy consumption of weighting account for 90% of the total consumption of energy in Korea and in forecast to increase by 2% each year until 2035. Various tests and policies are being implemented to reduce building energy, but there are no clear plans for residential buildings, which account for about 48% of the total building energy consumption. The increases in energy consumption of residential building was stagnant over the past decade due to stable electricity consumption by progressive residential electricity rated and improved energy efficiency of home appliances due to the energy efficiency rating system. Although residential electricity consumption was kept stable due to the household characteristics rather than the physical characteristics of buildings, many studies have been performed of conventional light shapes as a way to reduce lighting energy consumption in residential buildings by changing for the physical environment of building to introduce natural light. Previous studies applied a single light shelter system to building by driving the optimal shapes and angle, but did not consider difficulties in applying single light shape to high-rise building because of the height, wind tunnel, and wind load of the buildings. Another challenge is that the size and angle of the light shed will have a significant impact on the shape and design of the building envelope. Therefore, this study performs evaluation to compare the daylighting efficiency of double light shapes to single light shape when applied to the residential space to increase options and to design the optimal shape of the double light shed by comparing double light shapes with conventional single light shape to develop a light shape that has minimal impact on the shape and design of building envelope in the future. Method and scope of research. In this study, we measured the illumination by using the radiance program to evaluate the indoor uniformity according to the application of single and double light shape and propose a light shade that satisfies the optimal indoor illumination by changing the angle of the single and double light shape. For this purpose, this study was performed according to the traditional showing figure 1 below. First, we consider theories related to light shape as well as the necessity of this study through lecture review. This study also considered the illumination standard in Korea, present the optimal indoor illumination standard to evaluate light shade performance. Second, evaluated the performance of single and double light shape through the radiance program. Third, based on the performance illumination, based on the performance evaluation result according to indoor uniformity, we propose the optimal angles of the single and double light shape that uh, satisfy optimal indoor illumination. We calculated the result of the single light shape by setting the optimal angle, the height of the conventional single light shapes. In terms of the double light shape system, we fix the height of the double light shape based on the field studies and drive the optimal angle to obtain indoor illumination by changing the angles. Light shade system and conceptual diagram. As shown in figure 2, the light shade or natural daylighting system that introduce external natural light deep into the room by reflecting light on the reflector and the surface on the ceiling. It is a nature and architecture light control system that saves lighting energy and improves the quality of the visual environment. Light shades also prevent excessive light from entering the room through the window to create a uniform indoor light environment. The height, weight, angle, and reflectivity are variables that determine the daylighting performance of the light shapes. As light shapes are natural daylighting system, its performance is determined by external environment factor. Therefore, light shapes show excellent daylighting performance on days when the external illumination is high, but this performance can degrade significantly when the weather is cloud. In this respect, evaluating the performance of the light shapes according to external illumination is an important factor. And while related studies have been performed on single light shapes, there is a lack of research on double light shapes. Table 1 show various studies of light shapes which only consider the length, width, angle, reflectivity, and shape of the single light shapes as variables. As shown in Tab 2, the illumination standards for residential space in Korea are quantitatively presently in KS 3011. The illumination standards for residential space are classified into visual performance according to high general and low brightness, depending on the type of activity. In terms of visual performance according to general brightness, the minimum and maximum illumination for reading in living rooms detailed work in the office and general work in laboratory are 300 lux and 600 lux, respectively. Therefore, the performance elimination criteria in this study was set to 400 lux, which is the average illumination for visual performance according to general brightness. As shown in figure 3, this study installed a hinge to change angle to drive the optimal angle of the double light shade that satisfies the optimal indoor illumination. We changed the angle from -10 to 30 angle in 10 angle increment. The width of the double light shade was set to 300 millimeter as proposed in the simulation study on the performance illumination of light shade focus on the depth of space and the dimensions and angle of light shade by Lee. And the double light shade was installed at height of 1,800 millimeter and 2,300 millimeter from the floor. The operation procedure of the lighting shade purpose in this study in as follows. First, we configured 3 cases as shown in Table 3. For the instrument, case 1 consists of no light shape, while case 2 consists of single light shape, where the angle is controlled from -10 to 30 angle in 10 increment. Case 3 consists of a double light shape, where the angle is controlled from -10 to 30 angle in 10 angle increment. The angle control of the light shape satisfies of the optimal indoor illumination by percenting the optimal angle according to the solar altitude, which influences the external illumination. We changed the angle and performed radiance simulation focusing on the results that showed excellent daylighting performance to drive to optimal angle of the double light shade system. As shown in figure 4, we model case 1, case 2, and case 3 and perform the simulation by considering the dimension required for full-scale experiment. In the future, the size of the window was set based on a 40% window area ratio as percent into window design guidelines of the Ministry of Land, Infrastructure and Transport. The location of the illumination sensor in the simulation was based on the IES 4-point method. Based on the development study, the maximum and minimum external illumination from 10 a.m. to 3 p.m. for summer were set 808 million lux and 7 million lux, respectively, and 3 million lux and 2 million lux for winter, as is shown in table 4 below. The performance of the light serve according to external illumination was evaluated follows. First, we performed radiance simulation for the three cases above to evaluate the performance of the double light shape according to external illumination and derive the minimum illumination, average illumination, and uniformity based on the measurement. Second, for the case 2 and 3, we performed the simulation by changing the angle from -10 to 30 in 10 increments for summer and winter. Thus, we calculated the optimal angle of the double light shape compared to single light shape based on the management by changing the angles of case 2 and case 3. Result, we conduct the performance evaluation of the double light shape compared to the single light shape through the radiance program to solve the problem related to managing basic external light shape and degrade the daylighting performance due to low illumination by weather condition. The performance illumination results are as follows. First, the uniformity of case 1 was lower than those of case 2 and 3, and the uniformity of case 3 was higher compared to that of case 2. Second, in the double light shape proposed in this study, the second light shape was installed at a height of 2003 millimeter, which is higher than the conventional single light shape. Moreover, the double light shape introduced more natural light into the room and exhibit a higher uniformity compared to the single light shape. Thus, the optimal angle of the light shape was 30 angle in the case of the 30 angle in the case of the single light shape. For the double light shape, the optimal setting was actually when fixing the upper light shape to 0 angle and setting the lower light shape to 10 angle and 20 angle. In this study, we conduct the performance evaluation of the double light shape compared to the single light shape through the desktop radiance program to solve the problem related to managing basic external light shape and degrade daylighting performance due to low illumination by weather condition. The findings are as follows. First, the uniformity of case 1 was lower than of case 2, and uniformity of case 3 was higher than that of case 2. Second, the double light shape system, case 3, was evaluated to have a higher uniformity compared to the conventional single light shape system. According to the summer and winter season and angle setting. Thus, in the double light shape system, the upper and lower light shape were installed at a height of 2030 millimeter and 2300 millimeter and 1008 millimeter respectively. The optimal angle of the light shape was 30 angle in terms of the case 2. In case 3, the optimal setting was achieved when fixing the upper light shape to 0 angle and setting to lower light shape to 10 angle and 20 angle. The purpose of this study was to improve the daylighting performance of light shape. Purpose of simulation for problem related managing basic external light shape and provide a more comfortable environment for indoor equipment. In the case of the single light shape under specific conditions such as the summer season, the optimal angle was 30 angle, but the double light shape system was significant in introducing nature daylighting into the room at various angles and time periods. In particular, the uniformity was highest and fixing the upper light shape to 0 angle and setting the lower light shape to 10 angle and 20 angle. However, in the case of winter, the uniformity of case 3 was higher than that of case 2 when fixing the upper light shape to 0 angle and setting the lower light shape to 30 angle. However, there was no significant advantage compared to case 1. Therefore, the additional studies should be performed in the future by leaving the possibility of various circumstances and development. Thank you.